Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 2001. Number of pairs of interchangeable rectangles. You are given n rectangles represented by a 0 index 2D integer array rectangles where rectangles of I is equal to width of I, comma height I. Denotes the width and height of the ith rectangle. Okay, two rectangles I and j where I is less than j are considered as interchangeable if they have same width to height ratio. That's the more important thing. More formally, two rectangles are interchangeable if width I divided by height I is equal to width j divided by height j. Then I can say what? It can be interchangeable. Okay, and they don't want us to return the value. They only want what? The number of pairs of interchangeable rectangle in this rectangle array. That's it. Okay, let us understand this in deep manner. See here, if they have given this as our array, then see here, rectangle 0 with rectangle 1. So 4 divided by 8. They have given, right, width divided by height. If that width and height ratio are same, then we can say it as interchangeable rectangle pairs, right? So see here, 4 by 8, here 3 by 6. Both will leads to what? 1 by 2. Can you understand this? Okay, now 4 by 8 and 10 by 20. Rectangle 0 and rectangle 2. It also leads to what? 1 by 2. Now 4 by 8 and 15 by 30. It also 1 by 2 ratio. Okay, now 3 by 6 and 10 by 20. It also 1 by 2 ratio. Okay, fine. Now 3 by 6 and 15 by 30. It also 1 by 2 ratio. And 10 by 20, 15 by 30 is also 1 by 2 ratio. Can you understand this? So there are totally how many interchangeable pairs? Totally 6. Right? Okay. Now see this example here. It is 4 by 5 and another one is what? 7 by 8. Whether it is in same ratio? No, right? Beyond this, there is no simplification for these two numbers, fractions, right? Okay, now how to do this? So it is simple brute force approach, right? In simple brute force approach, what we are going to do? We are just going to take each every one of them fractions, right? Okay, let me take an individual array and put like, see here, first of all, this. So 4 by 8, comma 3 by 6, comma 10 by 20, comma 15 by 30. I will take like this. Okay, now I will simplify this further. If I simplify this, what will be my answer? My answer something like 1 by 2, here also 1 by 2, here also 1 by 2, here also 1 by 2, right? Now I will just take this as our first pointer. Now I will start checking from this whether these two are equal. Yes, then my result will be incremented by 1. Now I will go here, whether these two are same. Yes, now I will increment by 1. Then again whether same. Yes, so I will increment by 1. Now again I will take this as our new pointer. Now I will start checking from this whether these two are same. Yes, so increment. Whether these two are same. Yes, increment. Okay, fine. Now I will move my pointer here. Okay, now whether this and this are same. Yes, so I will increment to 1, right? Now again I will go here. Further there is no elements left, right? So I will stop here. So what is my output? It is 6. That's it. Simple, right? Okay, so it is a simple method, but you may ask how to reduce this 4 by 8 to 1 by 2. Instead of this 1 by 2, you can also keep it as 0.5, 0.5, 0.5 and 0.5. That's your convenience. Okay, whenever we are just dividing 4 by 8 in our compiler, it automatically takes into what? 0.5. Okay, it won't be like 1 by 2. It can be like 0.5 also. For convenience, I took like this. Okay, now for this approach, what is the time and space complexity? My time complexity will be O of n square. While space complexity will be what? I'm taking an individual array, right? Okay, it will be O of n. Okay, but we can also do it without using this extra auxiliary array also. Okay, we can directly take this as our array. Okay, then we can reduce this space complexity too. Fine. Now this time is n square, right? It is huge. Whether we can optimize it. Okay, let us analyze how to optimize it. See here. First of all, I want to check whether how many elements have same ratios, right? See here. Here totally four of them have the same ratio. So for this first element, I have 3 pairs. Then for this second element I have 2 pairs. For this third element I have 1 pair, right? Totally 3 plus 2 plus 1, like that. Okay, so something like if I count each and every same ratios, then it is easy to find how many pairs are present, right? Okay, let us understand and do it in better way. See here, that same numbers I will take 4, 8. Then let me copy this 3, 6, 10, 20, 15, 30. Okay, fine. Now just see here. First of all, I will take a hash map. Fine. Now I will take this element, and what is this ratio? This ratio is 1/2, which means 0.5. Okay, I will put 0.5 and increment my count as 1. Now I will go here. What is my ratio here? It is also 0.5, so increment by 1. I will go here. It is also 0.5, so I will increment my count as 3. Here also it is 0.5, so I will increment this count as what? 4. Okay, for our current example, we can take 2 more values, okay, of different ratios. Among them, it is same. Okay, let me take 3:11 is one array. Then another one is 6:22. Okay, now this will be like, I don't know what is the ratio, so I just keep it as 3/11. But in real time, it will be like in this decimal values. Okay, so it is 3/11, right? So I will increment my count as 1. Now it also 3/11, right? So I will increment my count as 2. Now understand this. If there are 4 count of 0.5, then how many values I can get? See here, it is like 0.5, 0.5, 0.5, 0.5. So by using this one alone, I can get 3 pairs, right? Okay, 3 pairs. Now again, by using this alone, I can get how many pairs? 2 pairs. This 2 pairs. Okay, now by using this alone, I can get how many pairs? 1 pair. Then by using this alone, I can get what? 0 pairs. So it is like a sum of n natural numbers, right? 1 plus 2 plus 3. So it is like sum of n natural number, but it is 1 less than, because here it is 4, but we gone up to what? 3. So what is the formula for sum of n natural numbers? It is n into n plus 1 divided by 2, right? So here it is 4, but we gone up to what? 3 only. So instead of n, we want to apply what? N minus 1. So apply n minus 1 into n minus 1 plus 1 divided by 2. So this minus 1 plus 1 cancels out. Now it will be what? N into n minus 1 divided by 2. Can you understand this? Okay, fine. Just stop here. Here also it is 2, right? 2. So it also comes like 1 alone. 1 pair. We can form 1 pair. So totally you can form 3 pairs of interchangeable rectangles. Can you understand this? Yes. We can easily put this formula. See here, if it is 4, then 4 into 3 divided by 2, which is equal to 6. Yes, if it is 2 into 1 divided by 2, 1. Can you understand this? So total is what? 7. Right? So what is the time complexity for this approach? So I can say time complexity will be O of, it will be n log n. You may ask why this log n? Because we are traversing each and every element and putting in this hash map, right? This hash map also takes some time complexity, which is log n. Okay, now what is the space complexity? It is O of n because of this hash map. That's it. Okay, let us see the code so that it will be more clear. See here, first of all, I am taking the hash map. Then result is equal to 0 for a comma b in rectangles. Now value is equal to a divided by b. I am taking the value, right? I am not taking the auxiliary memory for it to store the ratio values. I am just taking this as a val in a variable. Now if val not in D, then I will just declare a key called val in a hash map and declaring its count as what? 0. Then again in default I will increment the val count as +1, right? Now after doing this process, again I am putting a for loop, then I am just traversing to the values of the dictionary, and inside the dictionary I am just applying the formula that we have derived. What is the formula? N into n minus 1 divided by 2, and I am just adding in the result. That's it. Then I am returning the result. That's it. Thank you.